Hello students, myself Ashish Chawla. Today we discuss about some more on basic proportionality theorem. Now let's start with one question on BPT. Let's say there is a triangle. Let's say there is a triangle A, B, C, and there is a line DE which is parallel to BC. It is given that DE is parallel to BC, and it is given that the length of AD is 4x minus 3 and the length of BD is 3x minus 1 and the length of AE is 8x minus 7 and the length of EC is 5x minus 3. Now in the question it is given that D is parallel to BC and the length of AD, BD, AE and EC are given, and we have to find the value of x. So as it is given that D is parallel to BC, so we can apply the basic proportionality theorem. In triangle ABC, DE is parallel to BC, so by basic proportionality theorem we can say that AD upon DB is equals to AE upon EC. Now simply we put the values, that is the value of AD is 4x minus 3 and the value of BD is 3x minus 1. The value of AE is 8x minus 7. The value of EC is 5x minus 3. Now we just cross multiply it, that is 4x minus 3 is multiplied with 5x minus 3. 4x minus 3 is multiplied with 5x minus 3 and 8x minus 7 is multiplied by 3x minus 1. 8x minus 7 is multiplied with 3x minus 1. Now just multiply 4x with 5x, we get 20x square. 4x with minus 3 we get minus 12x. Minus 3 with 5x we get minus 15x. Minus 3 into minus 3 we get plus 9 equals to 8x into 3x we get 24x square. 8x into minus 1 we get minus 8x. Minus 7 into 3x we get minus 21x. And minus 7 into minus 1 we get plus 7. Now we converting, we are shifting all the terms to the right hand side so that we get equation 24x square minus 20x square, we get 4x square. Now minus 8 and minus 21 are getting added, it becomes minus 29. Now minus 29 here, minus 12 and minus 15. Okay, let's first we simply solve this. 20x square minus 12 and minus 15 get added, that is minus 27x plus 9 equals to 24x square minus 8 and minus 21 becomes minus 29x plus 7. Now we are shifting all the terms to the right hand side. So 24x square minus 20x square we get 4x square minus 29, when minus 27 is shifted to the right hand side it becomes plus 27. So minus 29 plus 27 we get minus 2x. Now when plus 9 is shifted to the right hand side it becomes minus, so minus 9 here. So 7 minus 9 we get minus 2 equals to 0. Now in this equation we get 2 common, so the equation becomes 2x square minus x minus 1 equals to 0. So 2x square minus x minus 1 equals to 0. Now we can factorize this. Now 1 is multiplied with 2, we get 2. Now we can factors 2 into 2 so that we get minus 1 here. So 2x squared, so minus x can be written as minus 2x plus x. So that minus 2 plus 1 we get minus 1. Minus 1 equals to 0. From these two terms we get 2x common. When we take 2x common, here x is remaining, here minus 1 is remaining, here again we take 1 common, so x minus 1 is 0. Now in these two terms we get x minus 1 as common. When we take x minus 1 common, here 2x is remaining and here 1 is remaining, equals to 0. So the product of these two terms is 0 only when either x should be equals to 1, the value should be x should be 1, or the value of x should be minus 1 by 2. Either x should be 1 or either x should be minus 1 by 2. But when we are putting x equals to minus 1 by 2 in length BD, we get the length of BD is negative. And we know that the length never be negative, so we neglect the negative value of x. So we neglect the negative value of x because when we put x equals to minus 1 by 2 in the length of BD, the length of BD becomes negative, so neglect minus 1 by 2. So our answer is x should be equals to 1. Answer is x equals to 1. Now we see the converse of basic proportionality theorem. The converse of basic proportionality theorem. So what will be the converse? The statement is that if a line divides the triangles, if a line divides the two sides of a triangle in the same ratio, then this line is parallel to the third side. This is the statement, that is, let's say there is a triangle ABC. In this triangle, there is a line DE. There is a line DE which divides the two sides, that is AB and AC, in the same ratio. The line DE divides the sides AB in the AC in the same ratio. Then this line DE must be parallel to BC. Okay. So in this question, in this statement, in the converse of BPT, it is given that DE divides AB and AC in the same ratio. It means AD upon DB is equals to AE upon AC. And we have to prove that, we have to prove that DE is parallel to BC. Now we have to prove that DE is parallel to BC. Now for this, we have to do one construction. Let's say we have to prove that DE is parallel to BC. Let's say, if possible, DE is not parallel to BC. Now there must be a line which is parallel to BC. Let's construct that line. Let's say DE dash, name as DE dash. Let draw DE dash parallel to BC if possible. Now in proof, in triangle ABC, it is given that DE dash is parallel to BC. Now as DE dash is parallel to BC, we apply BPT. So by BPT we can say that AD upon DB is equals to AE dash upon E dash C. E dash C. So in the given condition, let's say it be 1, Now let's say this equation with 2. Now when we are comparing these two equations, first and second, we see that their right hand side are same, that is AD upon dV, AD upon dV. So by comparing 1 and 2, by comparing 1 and 2, we can say that AE upon EC is equals to AE dash upon E dash C. Now we are adding 1 on both sides. When we are adding 1 on both sides, AE upon EC plus 1 is equals to AE dash upon E dash C plus 1. We are adding 1 on both sides. Now we are taking the LCMs. EC is the LCM. On the numerator we get AE plus EC. Here E dash C is the LCM. In the numerator we get AE dash plus E dash C. By figure we can say that AE plus EC is nothing but AC. AC upon EC. AE dash plus E dash C can be said as AC upon E dash C. So AC and AC get cancelled. We get EC is equals to E dash C. E dash C. Now E dash C can be written as E dash E plus EC. E dash C can be written as E dash E plus EC. Now EC and EC get cancelled. We get E dash E equals to 0. That is, the distance between these 2 points, that is E dash and E, is 0. It is possible only when E dash and E are coincide. It is possible that when E dash and E are coincide, so it means E and E dash are the same points. It means E and E dash are the same point, or it means DE and DE dash are the same line, are the same line. So we conclude that D dash is parallel to BC, or you can say DE is parallel to BC. So this is the converse of the basic proportionality theorem. That is, if a line divides the triangles, two sides of a triangle in the same ratio, then this line must be parallel to the third side. That is the converse of BPT. Thank you.